So some of you might be familiar with this little project called Chaos Monkey. Has anyone heard of this project before? So this project literally took years off my life. I used to work at a little company called Netflix, and I'd be working on something and it would just tear down everything I was working on. It was an absolute disaster. Yeah. So Chaos Monkey is an open source project put out from Netflix, and its point is to tear down everything, right? It's basically like Russian roulette for your servers. So let's give you an example of what that actually looks like. So this might look like a diagram of an application that you might build, right? You can see there that we have a database, a caching layer, a bunch of different services. I just modeled like a e-commerce website, right? So you have like a user service, a product service, a cart service, and in this particular case it's written in Go, but it could be written in anything, right? It could be written in Scala, it could be written in more Ruby stuff. And then you have a bunch of mobile clients that talk to those services, and then you also have a front-end service, which we'll say is something like Rails, that actually does the server-side templating, reading from those services, and rendering out. Pretty good architecture, right, I think? So let's talk about when something goes down, like something goes wrong. So let's say we had a problem in the front-end service. So it starts on fire, and all of a sudden everything around it starts kind of like feeling it. So you'll see actually downstream that like the server side or the computer clients actually start having problems as well, right? But the mobile clients are all still fine because they don't actually use the Ruby service. It's actually just the front end service that it's feeding those. So by looking at this from like a more topographical sort of way, you can see that you can kind of reason through your minds like there must be a problem with the Rails service, right? Because only the front-end clients are suffering and not the mobile clients. Does that make sense? So that's kind of what we're looking at is kind of these downstream problems. So now let's talk about something that might be a little bit more subtle. What happens if the caching layer sets on fire? Well, if the caching layer starts on fire, it's probably still going to keep hitting the database, but the database eventually is going to start getting overloaded because it's going to start getting more problems, and all of a sudden it's going to start on fire, and then everything starts on fire, right? But let's talk about why this is more subtle, why this is more insidious, why this is more of a problem, right? The caching layer is going to go down, and you don't immediately have problems. And that's hard, like that's a hard thing to look at because eventually you're going to look and say, oh, the database is down and now everything's on fire. There must be a problem with the database. But in reality, the database would have been fine if the caching layer hadn't gone down. So I want to talk to you about what is chaos engineering. Chaos engineering is a vaccine. So what is a vaccine? A vaccine is basically introducing chaos into your body so that your body can learn how to fight disease, right? It's introducing a small controlled amount of chaos. You're putting a little bit of a disease in your body so that you can build up an immunity that you no longer get those problems in the future. This is what chaos engineering is for distributed systems. You introduce small controlled little bits of chaos, and then you can see the problems, and then you can fix the problems, so you can fix those problems before they actually become problems. So, who am I? Why do you want to listen to me talk about chaos engineering? My name is Brian. I'm from Seattle, Washington. I just moved there. Previously was in San Francisco and Salt Lake City. Always been in the United States. And I work for this little tiny startup that you might have heard of. I work for Microsoft. I'm a cloud developer advocate. I work on Azure, which is our cloud provider. It's a really cool job. I've only been there for a couple months, but basically my job is to come out here and convince you that Microsoft has a cloud. It does. Before that, I worked at a little tiny other startup called LinkedIn. I was there for about 8 months, and I also practiced chaos engineering here. I was a front-end infrastructure engineer, so I was working with bundling things and those sorts of things. So we were introducing chaos into our front-end infrastructure to kind of just find the problems there. Before that, I was at Netflix, and before that, I was also at this other crazy startup. I say crazy in the worst way. Ooh, that's loud. So yeah, I used to work at Reddit as well. I was one of the directors of front end at Reddit. And yeah, I live in Seattle. Go Seahawks if you like football. Cool. So I have a confession to make to you. I don't actually write Ruby. I've actually never written Ruby before. So it's okay, you can boo me, that's totally fine. I'm okay with that. I'm a Node engineer. I've historically written Node for a long time. That's what I did at Netflix. That's what I did at Reddit. I focused a lot on Node, but also a front-end engineer. So I've done a lot of courses for like React.js, Angular, as well as that. So mostly I'm a JavaScript engineer. So I love JavaScript. I know some of you might disagree a little bit with me. Literally my least favorite thing would be to write Opal. That would be just crushing to my soul. These days I work less on Node and more on something called Kubernetes. How many of you have used Kubernetes before? Cool. I'm going to talk about Kubernetes, and hopefully by the end of this talk, you're going to be stoked about Kubernetes. Kubernetes is more infrastructure, right? It's more DevOps stuff. So you can take containers of applications that you write and containers of databases and caches and things like that, and they can do these large-scale orchestrations of deployments. But we'll get there. So the case for chaos. Chaos engineering is it's a lot of work. The idea being is that you want to tease out kind of the problems with your system. So there's a place called principlesofchaos.org. So I'll just read this to you. Chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. So to rephrase this, chaos engineering is so that you don't get paged. So I want to compare two different things to you. I used to work at Reddit, and whenever I was on call, I was gone the entire week. I was waking up every night at midnight. I was, working with servers on fire all the time. This is why Reddit is down all the time. It's because we didn't do chaos engineering, right? So when things broke, we were always discovering new things about our system. Now I want to compare that to Netflix. Netflix is a bigger company than Reddit. It has more traffic. 1 in 4 bits flying around the internet is a Netflix bit, right? So we're moving a lot of bits. I never got paged at Netflix. The entire 2.5 years I worked there, never ever got paged. Now don't get me wrong, sometimes I'd be working on things at Netflix and they would break because Chaos Monkey decided it didn't like me that day. But that was worth it, right? Like that was worth introducing the pain into my life so that I could handle these sorts of things. So this is kind of the case I'm trying to make for you for chaos engineering. And we'll kind of get to the more Ruby perspective here in just a second. So we're going to talk about from multiple perspectives here. the name of my talk is Chaos for the Front End, but I'm going to focus more on the back end for you because I think most of you are Ruby developers, right? Who in here considers yourself like primary a Ruby developer? Okay. Front-end engineers, does anyone in here consider themselves more front-end? I'm literally the only okay, cool. We'll just not talk about it. It's okay. Any DevOps people? Anyone do DevOps? Okay. Cool. So I'm going to convince you to work on all three of these because I actually love all three of them. So Chaos from the ops perspective is something like Chaos Monkey. It's something that Chaos Monkey is a server that you install inside of your own system, and you basically give it like a list of servers. It's like, hey, at random, start taking things down. Now, most of you think like this seems like a bad idea, right? I actively don't want servers to crash, so why am I making servers crash? And the reason being is that when these servers crash, you're going to start seeing how they affect other services around you. You'll also be testing the self-healing ability of your system, right? So ideally, when something crashes inside of your service, it informs you that it crashed, and then it self-heals, right? It'll actually spin up another server, put it into the new cluster of servers, and then go about, continuing, so that you can both fix the problem and not have any downtime. So when I was at Netflix, we actually had 5 nines of availability, almost. 1 year, almost had 5 nines of availability. If you don't know what that means Netflix had 99.999% of uptime, which is about 45 minutes of downtime a year, which is crazy. The only reason that we didn't get 5 nines is that in February of 2016, we had an hour and a half of downtime, and that ruined our 5 nines for the year. We weren't happy about it. The guy that brought down the servers for an hour and a half, he had a rough time. We'll put it that way. So this is what chaos engineering is from the ops perspective. It's putting something like Chaos Monkey into your service rotation. You give it a list of servers that it can take down. Obviously, you don't want it like taking down all of your databases all at once, right? So there's some sanity that you kind of introduce to it. You either whitelist servers that you want it to be able to take down, right? Or you blacklist servers that you don't want it to take down. However, you still want to be doing things like having, secondaries of your Mongo cluster brought down. You want primaries being brought down because you want to make sure that the election of new Mongo shards is actually happening the way that you intended for it to happen. So, I want to talk a little bit about a couple tools that kind of like lead you up to this point. How many of you are using Docker right now? Cool. So, after this talk, if there's one thing that I want you to go try, it's probably Docker. I think Docker is a really worthwhile piece of technology. Docker basically allows you to write code that creates infrastructure for you, which to me is awesome. I can basically create a Docker file that tells my server how to create itself. This is really great because then you end up with not having what we call snowflake servers. Snowflake servers are actually the one that they use is called pet servers, because pet servers are the servers that you love and that you put a lot of work into, and you fine-tune them just the way they want, and you pet them and you let them know that they're special. And then they crash and die, and then you're very sad that your pet is gone. So these are the things that you kind of want to avoid, right? Like we all do things like this, right? Like how many of you just like spin up a VM, SSH in, and just like start running your server and then get off it, right? I do that all the time. Docker removes us from what we call pet servers to what we call cattle servers, which is just that you have a ton of them, right? And they come and go, and that's totally fine. So you basically say like, this is a Ruby server. I want you to run these commands, I want you to install these gems, and then I want you to start the server. And this is really great because you can just say Docker up, and it just creates your server, and you're just off to the races. So this allows you to create individual containers. I guess it'd probably bears mentioning what containers are as well. So, in a VM, you have an entire guest operating system on top of another operating system in some sort of visor situation, right? This is really cool because you've kind of encapsulated these various different processes that they can't interfere with each other, right? Because the problem that you can run into if you don't have something like a container or a VM is things will start messing with each other and they'll start competing for resources. And if one thing crashes, everything crashes, which is a problem, right? That's what we're trying to avoid here. Containers actually make this even a little bit nicer for you to work with. Containers allow you to have multiple different processes inside of one VM. So you don't actually have to have multiple different operating systems. You're just separating things out using a couple Linux features like namespaces. So that's what Docker allows you to do, is it allows you to do these containers. And they're called containers because they're like shipping containers, right? You're allowed to like ship them to the cloud, and you're allowed to bring them back from the cloud, and you're allowed to ship them to your friend, right? So that's why containers are really great, is because they're portable. So, okay, now I've created my Ruby service. It's going to be a Rails-based service, and I've containerized it, and now I want to, connect that to MongoDB, or maybe something like, let's go with MySQL. You want to connect it to MySQL, and you want it to have caching, so we need something like Redis, right? And we also maybe have like a couple microservices or background daemons, or maybe even something like Apache Kafka, something that's going to do topics processing and queuing and things like that. Now, if I had to do this all by hand and I had a bunch of Snowflake servers, you can see how this goes south really quickly, right? I don't have enough hands to be typing all that stuff all at once, especially if it all goes down at once. So that's when we come into something that's called Kubernetes. I've heard this said like 13 different ways. I'm not sure if I'm saying it correctly, so don't copy me. Kubernetes, I've heard it said. Kates, I've heard a lot of people just call it Kates, right? So we're going to go with Kubernetes because I think that sounds the best. So now I have multiple different things that I want to deploy and have like a local instance of it running. We're going to use something like Kubernetes. Another thing that you could use here is something called Docker Swarm. I don't know too much about Swarm, so I'm not going to tell you any more than it exists, but you might want to check that as well. So Kubernetes is based on a project that was internal at Google some years ago, and it's the way that Google has been running containers for a long time. I saw a quote recently from one of their engineers that at Google, 1 billion containers are created and destroyed every day. That's crazy. That's a lot of containers. So Kubernetes is something that you can actually use to manage all of these different containers, right? So you have Docker, which builds the individual containers, and you have Kubernetes that does the large-scale orchestration of it. So it'll do things like load balancing and networking and a bunch of stuff that I'm not smart enough to figure out. Nor do I want to be, right? Like I want to rely on someone else's code to do those kind of things. I just want to build my application. I'm a developer, right? I'm not an operations kind of person. So that's why I'm fascinated with Kubernetes, is because it does things that I do not want to do. So if you want to run something locally on Kubernetes without having to have a cloud deployment yet, there's a thing called Minikube that you should definitely use to get started. It runs Kubernetes locally on your computer. It works on Mac, it works on several different platforms, so go ahead and give that a shot. Now again, I'm not an operations kind of person. I don't want to deal with networking or any of that kind of stuff because it's just not my expertise. And I don't want to spend a bunch of time learning it either. So there's 2 different tools that Microsoft has worked on and then open sourced the world. One is called Draft. And Draft is something like Yeoman, like it's a scaffolding tool. There's something like, I guess Rails itself does scaffolding, right? So it's like that Rails scaffolding thing that you can do. Draft is that, but for cloud infrastructure. So you just say like, hey, you know what? I think I need a Redis container. And you just say draft install stable/Redis, and suddenly you have a running Redis container inside of your Kubernetes cluster. That's magical for me because I didn't have to do a bunch of things. I just said, like, I like Redis, install Redis, and it just worked. There's another one called Helm, and Helm is like npm for Kubernetes things, right? So Draft uses Helm behind the scene, but you can also use Helm separately to kind of install various pieces of infrastructure. It's installable infrastructure. So also be sure to give Helm a look. So I had a demo here, and I think we're going to keep going, and maybe at the end we can talk about it. But yeah, let's keep going. So we'll come here in just a second. So why is chaos engineering useful for ops people? And I think we kind of already touched on it, is they get paged less, right? If I break infrastructure and I'm a front-end engineer, I'm not the one that gets paged typically. Typically it's the back or the ops person that gets paged first, right? And then they call you at 2 in the morning and say, you broke this, you ruined my sleep, and I hate you, right? So that's why ops people really like chaos engineering, is because it forces developers to acknowledge their problems first, right? So if you break things and then you can go to the developer and say, this broke because of your code, or because you didn't handle this kind of problem, or you didn't have this unanticipated edge case. So that's why ops people should be in favor of doing chaos engineering. So let's talk about the back-end perspective. I think this applies to most of you, especially as Ruby developers. Are Ruby developers very much talking about chaos engineering these days? I don't see very much about Ruby and chaos together. So I think this will be something interesting for your community to kind of get interested in. So none of us like to launch things that break, right? None of us like to launch things that that are going to cause other people to get paged or lose money, or any one of those things. So I think that's one of the first value propositions for chaos engineering for back-end developers, is it basically allows you to anticipate these kind of problems before they actually end up in production. There's a tool at Netflix called FIT. It's called Failure Injection. I don't know what T stands for, but you get the idea. So what FIT does is that you could actually go in and identify a microservice at Netflix and say, make that one fail for this particular user. And it will, anytime that user would make a request to that microservice, it would 500 or 404 or do something wild like that. And that was really useful for me when I was doing back-end work at Netflix, because I could go in and make sure that my service that I was building was resilient to every other service failing. Because eventually everything breaks, right? That's just a fact of life, that someone launches bad code, or there's bad latency, or there's a region that goes down, or something like that, or something times out. So that's a tool that you might consider using or building, is doing failure injection into your backend service. Because especially if you're doing a microservice type of deployment, you need to be resilient to other services failing. So this is why I like the backend perspective as well for chaos engineering, is because it lets you fix problems before they become someone else's problems, who is then going to make it your problem because they will see the Git blame. So front-end engineers really aren't talking at all about chaos engineering, because a lot of front-end engineers are like, that's not my problem, right? I don't care, but this is something that at Netflix we focused on a lot, because when you land on Netflix.com, Netflix tries its best to tell what kind of shows that you like, and then it tries to show you those shows, right? And that's a good incentive for you to sign up for Netflix if you're seeing the shows that you like. However, when we had an outage one time for the recommendation system, it caused the front end to crash. And when Netflix.com's front end crashes, That's literally millions of dollars every hour that are being lost because people aren't signing up for it. And it was being lost for the recommendation system, which is essentially non-essential, right? You don't actually need correct recommendations for someone to sign up. So that's how the front end needed to be resilient to these kind of failures in their system. You need to be resilient. It's like, hey, check if there are recommendations available for this user. And if that crashes, the whole process shouldn't crash, right? Like the whole site shouldn't just 404 or 500 or something like that. Or not allow the person to sign up. And so that's why failure injection and chaos engineering can be really useful for front-end people as well. It basically allows us like, hey, if this Ajax is slow, or if it's bad, or something like that, be able to recover from those sorts of errors. I wanted to talk a little bit about the server timings API. I checked, and there is a Ruby gem that allows you to do this. So something you should definitely look into and invest in, I think. So you can see here I have some Ajax call that's being called, and then I want you to call your attention to this. Let's see, I can't draw up here, but anyway, where the red box is, right? So this is the Chrome Dev Tools, and using a header, I send down with this Ajax request a bunch of additional information about what was happening on the back end, right? So this is inside my browser. You can see there that it's probably hard to see, but I'll read it to you. The cache took 300 milliseconds. It took 1.23 seconds of CPU time, 600 milliseconds of file system. MySQL lookup took 800 seconds or something like that. So this is something you can actually see side by side inside of like your timeline, inside of your Chrome Dev Tools. I hope you're already seeing how this can be useful to you, right? You can immediately identify inside of your browser, hey, my MySQL calls are taking way too long, right? This is slow, and this is slow because of MySQL. Like just from a web performance perspective, that should already just be like, yeah, this is a really good idea. But let's talk about this even further with chaos engineering in the mix. Now, whenever I'm running a chaos experiment, I can go check my browser like, hey, this MySQL call was 200 milliseconds before. Now I've had the cache fail, but now my MySQL calls are going up to 2 seconds, right? So you can kind of see the cascading effect of things failing. So that's another thing that you should be checking into. And again, usually you just have to say, you just time the various parts of your infrastructure and you just include those as headers on your Ajax calls. So just Google server timings API and most of that stuff should be available for you to check out. So now we're back to our application that we were looking at. What you want to do when you're doing these chaos experiments, these are often called game days. I don't know why, because they're not fun most of the time. And you want to go through each part of your infrastructure piece by piece and introduce failure into them to see what happens. So if I introduced failure to my cache, as you saw before, everything started on fire, right? Because if nothing's hitting the cache, then everything's going to the database. And if everything is hitting the database, then all my services are going down piece by piece. So you can see that you have a single point of failure inside of your infrastructure, and that's the cache layer. And ultimately, this is what we're trying to avoid as engineers. We don't want to have single points of failure, right? We don't want one thing to fail and have the whole system fail. We want to have resiliency. So if the cache fails, maybe like rather than just everything crashing, it spins up a new cache layer, it populates it as fast as possible, and then you're able to kind of keep going while the database is still able to keep up with all these requests, right? So this is essentially what chaos engineering is doing for you. It's finding the weak link, it's finding the single point of failure inside of your infrastructure. You'll also want to do it with your database. Sometimes you don't even necessarily have to take down servers, right? So first of all, with the database, For something like MySQL or MongoDB or something like that, you want to make sure that if the primary goes down or the master goes down, that a new master is brought up, a new primary is brought up, and that everything is rerouted correctly, right? And that the sharding is happening and all that kind of stuff. So that's why it's really useful from the database perspective, is you want to make sure that all these different election processes are happening correctly. Same with, Cassandra has relatively similar issues as well. You also want to make sure, like, for example, if the cart service is going down, you don't want your home page to go down. Like, obviously, if the cart goes down, they can't access their cart. Like, that just kind of happens. But you want to make sure that the user service still works, and the product service still works, and that you're not 404ing on the home page. So these are the different parts of your infrastructure that you definitely want to be checking into. So we talked a little bit about failure injection. There are tools out there. I'm not sure what they would look like for Ruby, but I'm sure if you search for failure injection Ruby that you'll be able to find some tools for it. And basically you want to go in and you want to try introducing latency, right? For example, if my user service took, a second to respond versus 200 milliseconds, you still want to account for those kind of eventualities that might happen. So that's why failure injection is useful as well, is you want to introduce latency, and you want to introduce, malformed responses and things like that. So going back to Principles of Chaos. Principles of Chaos is this, it's a website I highly suggest you reading. It's basically a manifesto of here are things that you want to work on if you're going to adhere to chaos engineering. So you want to build a hypothesis around steady state behavior. This is really fancy talk for basically you want to know what your system looks like when it's healthy, right? And you want to not be reliant as much as possible on stateful servers, right? If you're ever carrying state on your servers, you're going to have a bad time. I promise, it always bites you in the ass. So build a hypothesis around this steady state behavior. You want to vary real world events. That's what chaos engineering is basically trying to do, is you build things in this perfect walled garden where there are unicorns and falling stars and things like that, and everything's beautiful inside of your local environment, right? Works on my computer, basically, right? Chaos engineering, the idea behind chaos engineering is that the world is not full of unicorns and rainbows, right? Things break in production, and there are regional outages, and there are all these kind of different things. Actually, at Netflix, they have a tool called Chaos. In addition to Chaos Monkey, they have Chaos Kong. Has anyone heard of Chaos Kong? Might imagine what it does. It takes down an entire AWS region at a time. It just crashes the whole region. And that sounds terrible, but the reason what they want to do that is they want to make sure that if US West goes down, that everything correctly routes to US East or to Europe or something like that. So that even if AWS has entire outages or Azure has whole outages, which happen, right? That we're able to reroute that to somewhere else. So that's the point of chaos engineering, is you're trying to simulate more real world environments, real world failures that aren't going to happen on your local environment, right? You're not going to have regional outages on your local computer. This one's hard for a lot of people. Run experiments in production. Why? Why don't I just run it on my staging environment, right? Because that way I'm not going to actually affect end users. If I run it in production, I'm going to affect end users. The reason being is that you don't care if staging is resilient, right? I don't actually care if staging has downtime. I don't care if it breaks. If something happens in production, or if something happens in staging, I'll fix it later, right? Because I have more important things to do. However, if stuff crashes in production, I have to fix it now. And that's why it's useful to do these things in production, is you're actually trying to make your production environment be the resilient one. And the only way you get that done is by running these experiments in production. That's why you have to run these things in production. It'll actually teach you how to be truly resilient in a production setting. When you're first starting out to run chaos engineering, you kind of do it by hand. a bunch of my friends work at a company called Gremlin, which is a company that's based out of San Francisco, and they do this kind of chaos engineering as a service. And they recommend that you start by like actually manually doing your experiments, right? Going in and try crashing your browser, try crashing your database. Now try crashing one of your servers, and all these kind of various different things. Eventually, you want to get to the point where you're not doing it by hand, that it just happens, right? That you say, okay, Chaos Monkey, here's the revolver. I don't know when you're going to start shooting things, but I guess I'll be ready for it, right? And when you have that uncertainty that things are going to be happening continually, you eventually are going to have a system. Well, one, either you're going to like pull all of your hair out and just like live on a mountain and not look at computers anymore, which might happen, or your systems are eventually going to be so resilient because they're literally going to be susceptible all the time to this chaos that you're always going to be ready for chaos, right? Which means that when there actually is a regional outage, it's going to be like another day at the office. I remember going into Netflix one day and they told me, there was a regional outage yesterday. I was like, oh, cool. I had no idea, right? Because I was already prepared for Chaos Kong because it had already ruined my life. Minimize the blast radius. So things that are not useful to do, don't crash multiple things at once, because that usually doesn't happen. It's kind of the idea of Occam's razor, that usually the simplest thing is the thing that's actually true. You don't want to be taking down multiple things. You actually don't want to try and cause downtime, right? You want to introduce chaos into your system so that you always have uptime. So make sure that when you're taking things down, you're only affecting the services that you want to. And then on the flip side of this, when you're minimizing downtime, you want to make sure that when one service go down, it doesn't affect the servers around it, right? So that's kind of what it means by blast radius, is that if one thing blows up, you want the blast radius to be as small as possible. So like I said, I work at this company called Azure, or rather I work for Microsoft and I work on the Azure product. Azure has a bunch of tools for this for you. So we have things called like service fabrics that you can actually kind of do these monitoring real time. And something really cool that we were doing now is we're actually monitoring your uptime and kind of saying like, hey, we saw downtime here, and we'll send you alerts to kind of let you know. It's like, we think that these are the problems. Like you have an outdated version of MySQL which has this problem, and you would encounter this exception and these kind of things. And we're actually introducing more and more ways to intentionally cause kind of chaos in your system as well, with tools that are built directly into Azure. So I would definitely invite you to give it a shot on Azure. It's really really straightforward and pretty fun. And there's a really good free tier so that you don't actually have to pay anything up front. You can run these experiments by yourself for free, which is pretty cool. Tools of chaos. So we already talked about what Azure has. If you have any more questions about what Azure is doing with it, please let me know. I want to talk about some other free open source ways of doing chaos in your system. One of them is the Simian Army, which that's what Netflix puts out. One of them is Chaos Monkey, one of them is Chaos Kong. These are the two kind of bigger tools, but they also have like Security Monkey, which will actually go on and do like chaos engineering, but more from a security perspective, and try to hit your site with SQL injection and cross-site scripting, and it'll actually try and go and do these kind of chaotic things from a different perspective. I know Cloudflare is working on something called Chaos Design, which is while you're doing development that it'll switch languages on you, and it'll switch viewport sizes. It'll switch like from 2G to 4G and 4G to 3G, and so that you're constantly seeing your site redone in various different ways, so it introduces chaos into the front-end engineering. These principles are not just for operations, they're also for everyone across the entire stack. It's not open source yet. So I don't know what they're going to call it yet. It's pretty cool though. But follow Chaos Design, or Cloudflare's design team, and I'm sure they'll announce it soon, hopefully. Spinnaker is also from Netflix. I talk a lot about Netflix, one, because I work there, but they're kind of on the forefront a lot of these ways on chaos engineering. It's something that every layer of their engineering team practices, despite the fact that chaos engineering was actually invented by the founder of Gremlin. I won't say invented. He was on the inventing team at Amazon. So this actually kind of all started at Amazon, and then it spread to Netflix, which really kind of took hold of these things. But yeah, so Spinnaker is kind of it's a tool for monitoring like all of your infrastructure and seeing the topography and those kind of things. And now Chaos Monkey is actually built directly into Spinnaker, so you can actually do chaos experiments directly from your deployment tool, which is from Spinnaker, which is open source, and it works on any cloud. So also be sure to check out Spinnaker. And then lastly is Gremlin, which is the one I was talking about before that my friends work at. That's the logo, which I thought was pretty cool. I should have worn I have a t-shirt with on it, but I didn't bring it. It's not free. They do not have a free tier, so that's something I'll tell you up front. I'm sure if you ask nicely, they might give it to you, but it's a really new company, so they're still kind of in startup land. Well, they're definitely still in startup land. Gremlin will actually do these kind of chaos experiments for you. Their tagline is resiliency as a service, so definitely keep an eye on Gremlin. They're doing really cool stuff. So yeah, that's everything I have. Does it